Students, welcome to the class of Technomaths. So today we are taking one question from metals, surface area, volumes, the day chapter from mensuration. Okay. So this question I have selected for the coming examination, board examinations. Okay. So this is a good question. Even you can understand the concept underlying. Okay. So two spheres are given to you. Two spheres are given to you. Okay. Let us say this is one sphere of 1 kg and another sphere whose all these spheres are made up of metal. Okay, made up of metal, and one is one, the weight of one first sphere is 1 kg. This is 1 kg, and another is of 7 kg, right? So it will be definitely bigger than the previous one. Okay, this is of 7 kg, right? And both these spheres are made up of metal and they are melted. If they are melted, then it's given that the radius of the smaller one is 3 centimeter. So the radius of this sphere is nothing but 3 centimeter, the smaller one, right? It's given that the two spheres are melted to form a single big sphere. This is melted and this is also melted, and the metals of these are, the molten metal are kept in a single atmosphere, and it is formed a and they formed a big they form a big sphere. Let us say this is the bigger sphere, right? This is happening. Okay, this is the big sphere. Now it's given that the two spheres are melted to form a single big sphere. Find the diameter of the new sphere. So if this is r, it has been asked that what is the value of 2r, that is the diameter, right? That is the diameter. This need to be calculated. Now students, this is the only data which is given to you. How to proceed forward? Just see. The radius of one of the sphere is given to you, and the radius of this sphere is not given to you. If the radius of this sphere is given, we know the formula of volume of a sphere, that is 4 by 3 pi r cube. Then if we are knowing the radius of this and this, both the spheres, then ultimately this would be calculated. But here it's not given. What is the radius of this one is not given to you. Okay, the r1 over here is known to you. R1 radius 1 of the first sphere is known to you, that is 3, right? It's 3 centimeter. And if the radius of the second sphere is R2, right? This R2 is not known to you. R2 is not known. If it would have been known, then definitely 4 by 3 pi r cube will be the volume of this solid metal sphere. 4 by 3 pi r2 whole cube will be the volume of this metal sphere, and you just add it and equate it with 4 by 3 pi capital R cube, and then on solving we will get the value of R, and accordingly we get the value of 2R. But this R2 is not known to us. This is the big challenge which we are having with us into this question. So to proceed forward, what to just think how to go ahead. The only data which stitches the things together is this weight 1 kg and 7 kg. You know how actually the mass of both the spheres are known to us, and it's also given that these are made of same metal. So if these spheres are made of same metal, these spheres are made of same metal. If they are made of same metal, these two spheres are made of same metal, then definitely they must have same density, isn't it? If they have same density, then we can say that this is the data which we can correlate. If they are having the same density and we know the relation mass per unit volume is nothing but this density, right? Now students, into this case, from the first sphere calculate the density. So density of this R1 is known to you. The smaller sphere will be the density of this bigger sphere, right? So we can calculate this, we can just equate it, because this mass per unit volume is the density and density will be constant. Density will be constant. Why constant? Because they are made up of same metal. So let me write density of a smaller sphere with radius r1, right, should be density of a smaller sphere with radius r1 should be equal to density of this bigger sphere not biggest, I'm just telling the bigger, the middle one, equal to density of bigger sphere with radius r2, right? Because both are made up of same metals, then density would be similar, equal. Now what we will do, we will simply equate it. So mass per unit volume, so 1 kg is the mass of 1 kg is the mass of a smaller sphere, and 4 by 3 pi into r1 cube, this is the volume, right? This is the volume of the smaller sphere, right? This is the volume of the smaller sphere, 4 by 3 pi r cube, right? This one. This would be equated with the density of the second sphere. This is mass of this is 7 kg, you can see. So it will be 7 divided by 4 by 3 pi. This is the volume, this is the formula of the sphere. Volume of a sphere is 4 by 3 pi r cube. So here we will be using r2 because this is the second sphere, right? So here you can see density of first sphere, this one, is equal to density of the second sphere. This relation we have used. Now from here you can see 4 by 3 pi and 4 by 3 pi can be cancelled. And we have the value of R1 as 3 here. So just put up the value. So we get R2 cube as equal to, we get the value of R2 cube as equal to 7 into R1 cube, 7 into R1 cube, right? And this one will coming to the denominator, and it will be as it is. So it will be 7 into r1 whole cube. And what is the value of r1 over here? R1 is nothing but 3. You can see R1 is 3 centimeter. So R2 can be calculated as R2 cube will be calculated as 7 into 3 into 3 into 3. 7 into 3 cube. Right? So this will give you 9, 3 into 3, 9, 9 into 3, 27, 27 into 7. Right? So this will be 27 into 7. This will be coming as 189. R2 cube is calculated now. Now, since we know the value of R2 cube, let us use this relation to calculate this R. Now we have the value of R1, we have the value of R2. Now it's very easy to calculate this capital R, the biggest sphere which is formed. What we will do, just volume of a smaller sphere, volume of a sphere with radius R1 plus volume of a sphere with radius R2, right? Both of these will be added and we will get the volume of the biggest sphere, that is 4 by 3 pi into capital R cube, right? Now here what we will see, volume of this sphere with a smaller r1 will be equal to 4 by 3 pi into r1 cube. R1 is 3, so this will be 3 cube plus volume of a sphere with r2. R2 cube is known to you 189, so this will be 4 by 3 pi into 189, directly putting up the value of R2 cube. So here you can see 4 by 3 pi will be cancelled out. 4 by 3 pi, 4 by 3 pi and 4 by 3 pi will be cancelled out. And we have the values with us, that is 3 cube plus 189, right? 3 cube is 27. 27 plus 189 is equal to capital R cube, right? Now just add it. 9 plus 7 16, carry 1. 8 plus 2 10 plus 1 11, carry 1, 1 1 2. So 216 is the value of R cube, right? Now just take the cubic root. Just take the cubic root of the LHS and even the cubic root of the RHS. Then we will be having R, capital R into the RHS, and the cubic root of 216. What is the value? What is the cubic root of 216? Tell me. The cubic root of 216 can be calculated if you just multiply 6 with 6. This is coming as 36. And multiply this again with 6. 6 into 6, 36, carry 3. It is coming in 216. So cubic root of 216 is nothing but 6. Right? So the value of r equal to 6 is calculated over here. Capital R is calculated as equal to 6. This r is calculated as equal to 6, right? Here this r is calculated as equal to 6. If this r is calculated as equal to 6, then what we will do? We will simply and easily calculate the value of diameter, because here if r is calculated as equal to 6, this 6, right? This r is calculated as equal to 6 here, then diameter, this is the question which has been asked to us. What is the diameter of this biggest circle, biggest sphere? If the radius is known to you, diameter is simply 2 times r, that is equal to 12, right? So students, in this way we have solved this question. Okay, so I think you liked today's session, and this question was very good. I just selected this question because the concept of mass, volume, density, radius, diameter, volume of the sphere 4 by 3 pi r cube, all these concepts are stitched together, right? So thank you so much for watching, students. Take care. Bye bye. Be connected. Keep on learning. Happy learning. Bye bye. See you. See you, my dear friends. See you.